Oh.
It'll say your pauses.
Okay, everybody, let's get started. Welcome back. Seems like forever since last semester. I guess you guys might have had earlier classes. This is my first class of the semester. This 1 day a week meeting has been was interesting from the start of the semester perspective. So this is INSY 6450. This class has been in the works for about 3 years now. First time it's ever been offered. It's been twice delayed because of COVID. And so I'm happy to finally be here and be able to teach the class. We also have a 5450 section, so I see some undergrads here. Most people I see here I know. I see a couple people I don't know. So for those of you who don't know me, I'm Jeff Smith, a professor in the IE department. And so what we're going to do today, we're going to do some brief introduction. I can barely talk, by the way. I'm kind of losing my voice. So kind of odd the first day of class, but yet here we are. And in the introduction, we're going to just spend a few minutes talking about some of the general concepts that we'll do for the semester. What do we mean by planning and scheduling? Where does simulation come in? Industry 4.0, digital twins, how those terms or how we're going to interpret those terms. Theory versus application. Then we'll spend some time talking about the course administration, syllabus, and some of the other material that I have already mentioned on Canvas. And then I'm going to talk a little bit about case study 1, which I had already posted to Canvas. So that is what we're going to do today. My guess is we're going to be about 45 minutes, maybe a little longer, and we will go from there. Okay, so let me do some introductory stuff first before we get to the administration of the class. So scheduling. What do we mean by planning and scheduling? So the title of the course is Simulation-Based Planning and Scheduling. Planning and scheduling are very general terms. And so they generally, both planning and scheduling, refer to the allocation of resources over time. And the difference typically between planning and scheduling has to do with level of detail and granularity, abstractness, and so on. And so when we talk about scheduling, we're going to interpret it as a kind of a standard representation here where we have a set of resources and we have a set of jobs. And those jobs need to be serviced somehow on the resources. And so you can see here I have 3 resources and 7 jobs. And what you see to the right of each one of the jobs is the sequence that they need to be serviced. And now we typically talk about this, or I typically talk about this in the context of manufacturing systems. Resources being machines, jobs being parts or batches or something like that. But it's much more general than that. So we can think of these as patients at a healthcare clinic. We can think about these as people going through some type of service system, right? And they have the same basic concept that I have resources where I have limited capacity. And I'm trying to process the jobs through those resources. And so a standard representation of such a schedule is something called a Gantt chart, which I have right here. And so here's one potential schedule for this set of jobs. And you can see this Gantt chart representation. We have the resources listed you can think of those as rows. And then each one of the tasks or each one of the operations on the job showing up where they're processed on the corresponding resource. Okay, this is a really simplistic representation. And for this representation, with this, at least how I have it shown here, we have a couple of assumptions about constraints to how we allocate tasks to positions, right? So we're assuming here that each one of our resources has capacity 1. And so that's why, for example, J1, job 1, and job 3 have to be sequential. Because we're making the assumption, at least in this chart, that resource 1 can only process 1 at a time. If it could process 2 at a time, those would both show up at the same time, starting at the same time. We also have precedence constraint, and so you can see that's why job 1 here ends at whatever time this is on resource 1 and then picks up here on resource 2 subsequent time. So there's a precedence constraint saying I can't do that second operation on R2 until I finish the first operation on R1. Okay? Now, those are assumptions that we're making, and those don't necessarily have to be true in all situations. So I can have parallel activities. I might have activities for a job where I can use R1 and R2 simultaneously, right? In which case they would both line up starting at the same time, potentially. Okay, and so what I have here is the standard representation, and then I have a second potential schedule where in this case I think I flipped a couple things. I moved J3 to be in front of J1, and I moved J7 to be in front of J2. It looks like pretty much everything else is just the same. And so this idea of this task of scheduling basically is saying I want to take that set of jobs and the corresponding requirements and the corresponding constraints, and I want to build a schedule such that I meet some objective. And that objective might be something like minimizing make span. So in this context, make span would be the time that last job finishes. So maybe I want to set up my Gantt chart or set up my schedule so that I minimize this the furthest out time. Or maybe I have priorities associated with the jobs. I have important customers or important people. I want to get them done first. I might have due dates, right? There's some objective that I do. And the whole task of scheduling says, I'm going to take these requirements and constraints and construct a corresponding schedule. Okay? When we talk about planning, what I have is just kind of a traditional production planning process. So again, I'm going to talk generally in the context of manufacturing, but it doesn't have to be. All of the things that we're going to talk about apply equally well outside the domain of manufacturing. It just happens to be the domain that I know the best. So when we talk about traditional production planning process over here on the left, typically start with something called in-item demand. So if someone is forecasting what the demand for a product is going to be or an item, you go through, develop something called a master production schedule. A master production schedule, unlike the schedules that we just saw, typically thinks about doing things in time buckets. So you might think of having, say, a 6-month forecast for demand that I then bucket into production by weeks. Right? So I'm not saying exactly when I'm going to produce something, but I just say I'm going to take this demand and I'm going to put up in a bucket of a week, in weekly buckets. And that's master production schedule. Go through something called rough cut capacity, or you incorporate rough cut capacity. And then you go through this process that uses MRP, material requirements planning, where you have this concept of a bill of materials. Okay, and so the bill of materials, I have a really simplistic one here that says, okay, so here's my level 0. So when we talk about in-item demand, it's like demand for that item. So item A, whatever that is, maybe it's a car or a computer or something like that, right? In order to produce A, I need a whole set of items. In this case, I have two major subcomponents, B and C. So you can think about B as being purchased, because it's a leaf here in my bill of material. And C is also something that I have to schedule and produce. And so it has 3 subcomponents, D, E, and F in this case. So when we think about this in production planning context, what I'm doing is I'm doing a master production schedule for A. But in order to produce A, I have to do all of this other stuff. So I have to make sure that I have B. I also have to plan production for C. And in planning production for C, I have to have, D, E, and F, whatever those happen to be. And so this planning process says, I'm going to take this end item demand, divide it into weekly buckets, but then I have to get down to this lowest level demand, and all of that happens down in this area here. Okay, so when we talk about planning, what we're generally talking about is that same thing of allocating resources over time. Because when I look at a master production schedule, that's what it is. It's just not quite as detailed as what we saw before. Right? It's doing things in larger scale or larger buckets than scheduling. Okay, so when we talk about planning and scheduling, that's really what the 2 major things that we're talking about. And all of these things we're going to talk about in a lot more detail, by the way. So today, we're just introducing the concept. And I'm sure most of you, especially all of the people who are IEs, have seen this a lot. Okay, so we're going to talk a little bit more about that. So then the next question is, well, where does simulation come in? All right, so this is simulation-based planning and scheduling. Where does simulation come into play? Our definition of simulation, or the brand or the type of simulation that we're going to use here, is discrete event simulation. And in discrete event simulation, what we have is we represent our system, and then we track the system state as it evolves over discrete time. Okay, we track the system state as it evolves over discrete time using something called a future event list. We generate something called an event calendar or a sample path. Okay, so the one example that I have from the video module 1 that you might or might not have seen, I have a simulation model of a tandem queuing system. So my tandem queuing system, I have two machines, S1 and S2, and all of the parts have to go S1 to S2, have different processing times, and they arrive at different times. Okay, so I have this general process where parts flow, and in this one, the one that I'm going to show right here, I'm using an arrival table. So rather than having random arrivals, I have specific arrivals that occur at these designated times, and the processing times at S1 and S2 are deterministic. So I'm not sampling random variates. I'm just processing those using specific times. And so when I execute my simulation in this discrete event paradigm, you can see what's happening is I'm actually performing, or the system is actually enacting what would happen. And down here is my calendar. It's kind of hard to see because I have it going so fast. But time is advancing in discrete chunks that are not equal. Right? So what happens is that the simulation, the model tracks when something important happens, and then it just jumps ahead in time until that next important thing happens. Okay, and then it calculates, well, when is the next important thing going to happen? And then it jumps ahead in time to when that happened. And the model, the constructed model, implements all of the constraints that I have. So constraints in this system say have to be processed by S1 and then by S2. Capacity of S1 is 1, capacity of S2 is 2. Same constraints that we had earlier in my initial example. Right? And what the simulation model does when I execute it is it implements all of those constraints. And then what it generates is a sample path. So if I go look at my results, those of you who, I'm assuming most of you have had Simeon, but we're used to looking at the statistical analysis or the statistical computations from that sample path. But if we think about it from a scheduling context, that sample path also represents a schedule. Right? So if I look at Simeon in the resource Gantt, for example, you can see that it's producing a Gantt chart exactly like the Gantt chart that we saw back on the first slide. Right? So what it's doing is it's saying, okay, well, I'm going to implement those constraints. I'm going to walk through the system. And as it tracks all of that in the event calendar, we can then go back and say, hey, what's the schedule that run of the simulation created? And that's what you see right there. Okay? So we think about what the schedule does, or what the simulation lets me do, is it lets me implement what we would think about as an accurately constrained model. Okay? And then it creates a sample path, and we use that sample path to construct a schedule. Okay? Two things here that are important. This accurately constrained. Okay, so if you think back to the Gantt chart that we have here in the very beginning, go back and see one of those. We really only implemented two sets of constraints, right? We implemented the constraints that say each resource can only be processing one at a time, and the precedence constraint on the operation. But in a lot of systems, you have much more detailed constraints. So for example, in a manufacturing system, I might have operators. I might have a person that has to go do something like set up R1 for J3, and then go set up R2 for J5, and then go set up R3 for J7. If I have one person, that has to be done sequentially. If I have two people, then two of the machines or two of the resources are going to be serviced. One of them is going to have to wait. Okay? I might have tooling constraints. I might have priority constraints. Right? So I have a whole set of more realistic constraints that I need to implement. So what's traditionally done, and what you see all the time, is companies will use software or will solve a scheduling problem like this in the abstract and then hand that to a planner to say, okay, now make this work. Okay, so what that means is let's implement the capacity constraints, let's implement the setup constraints and the operator constraints and all that kind of stuff. And so there's this secondary operation between generating the schedule and creating something that you can actually do. And that's what we mean when I said on the other slide, an actionable schedule. right? Because if you think about setup constraints and so on, these aren't actionable if they have those secondary constraints. Right? It's a plan, but it's not actionable because I have to incorporate, again, just think about the case where I have one operator who has to do a setup. I can't start all three of these at time 0. Right? Someone has to go in and say, okay, I'm going to have the operator go here first, then here, then here. Okay, and so you take that abstract plan and then create an actionable plan. Okay, from a simulation-based scheduling perspective, I can do all of that in the simulation. I can incorporate that notion of secondary constraints and setups and all of that stuff in the simulation, so the resulting schedule that I get is completely actionable. And so you eliminate the need to have that secondary process where you have a planner or a group that does that manual planning. And the plans that you generate, the schedules that you generate from your scheduler are completely actionable. And because they're completely actionable, I can analyze them. And I can try other plans, right? And I can look at impact on overall system performance. Okay, so that's the basic idea that we're going to follow, is that we want to use the simulation to generate completely actionable plans that I can then optimize, or at least try to optimize. So it's not really a new idea, right? So we were doing, personally, I was doing simulation-based scheduling in 1990, right? But there's been technology advances that make it a lot more practical to do these days. And so computing power, obviously, has changed quite a bit. Ubiquitous database connectivity, so I can have access to all of the information that I need virtually instantaneously. That coupled with cloud computing makes all of the information that I need available. Right? So you've got this theoretical ability to create actionable schedules, but if I can't get all the information, I can't do it. I can't do it in practice. And that's where we were, prior to some of these more recent advances, is that theoretically it would work, but without access to the information, you couldn't make it work. In other words, just think about the case where I have an operator requirement. I need to know the operator's work schedule today. I don't need to know that, in general, I have 2 operators. I need to know who's going to be there today, what time they go on break, what time they go to lunch, what time they get off, right, in order to be able to create an actionable schedule. So I have to have access to all of that information. And that's what this database connectivity and cloud computing have done. Software interoperability through APIs. One software system can easily talk to another software system. And then just advances in simulation software that incorporates a lot of these technologies have allowed that to happen of late. So Industry 4.0, digital twins, and us. Everybody's heard Industry 4.0? Anyone not heard of that term? Everybody heard digital twin? Everybody heard that term? So there are no definitions of those terms that are universally acceptable. These are very buzzwordy things that people have been talking about over the last, say, 5, 6, 8 years, but there are no universally accepted definitions. Okay, when you talk about Industry 4.0, we're generally talking about connectivity, having things that are highly connected. Okay, so all of my systems are connected. I know where everything is. If you think about that from a discrete event simulation standpoint, what you're really saying is I have a perfect map of my system state, right? I have a perfect map of my system state. Not just inside my simulation, but in my real world. For my real world, I have a perfect map of that because everything is connected and everything is talking to everything else. Okay, and that's really what our focus on is having a system where we have that complete connectivity. And with that, this notion of a digital twin says, hey, if I have a high fidelity model that has the same connectivity ability, so I can talk to my ERP system and I can talk to my manufacturing execution system, I can talk to PLCs and I can talk to forecasting systems and so on, right? Then I can create a model that will behave exactly like the real system will behave. Okay, and so our notion of a digital twin is that I have this computer model, in our case a discrete event simulation, that can connect to all of the systems to provide the information that we need, and that will react exactly like the physical system would react. Okay, so that's what we mean in this class when we talk about a digital twin, is that we are creating a model that will behave that way. Okay? If you think historically about simulation models, usually or typically, traditionally, a simulation model is something that's called purpose-driven. So I build a simulation model with a particular objective in mind. Right? So people all the time, if those of you who had me for simulation class, one of the things we always talked about is, I want to build a simulation of system X. The first question is, well, what do you want to learn from it? So what do you want the system to, what do you want to learn from the model? Okay? In the digital twin space, it's a little bit different. What I want is a model that behaves exactly like the system, and then once I have it, I can ask it a variety of questions, I can exercise it to do a variety of planning and scheduling tasks, but I don't really have a specific objective in terms of performance analysis. I'm just building something that I can use for a variety of things where I would like to know how a system would react, but I don't want to do it in my real system. Okay, and so that's what we mean in this class when we talk about digital twin. And we'll talk again more about these basic concepts. We're not going to talk too much more about Industry 4.0 by definition, but we will talk about all of these different connectivities, where they come into play in a general planning and scheduling context, and things like that. Scheduling, theory versus application. So over here you've got on the theory side, mathematical formulation of scheduling problems, optimization, things like computational complexity, what's the order of the solution, heuristics. Over on the right side, we have software training, templates. So I have a system, I use a template-based model where I can just sort of plug in the data from my system and then it generates my schedule. Okay, so we have on one end, we have the theory. On one end, we have the application. And we're going to be, at least our target is somewhere around here. We'll do a little bit of theory. For the people who are into theoretical scheduling, they would say we do no theory in this class. For the people who do no theoretical scheduling, they'll say we do a little bit of theoretical scheduling. But we're not going to be all the way on the application end either, because what we want to know is how things work and why they work and so on. So we're going to take a more generalist approach than a training approach would be, where I'm trying to train someone, for example, to build a model of a specific system. Our target is going to be right around there. Okay? But do you have any questions for me so far? Okay. So let's talk about some administrative details for the course. That's my introduction, by the way. First of all, let's talk about the syllabus. So I have the syllabus. It's on Canvas. It's been on Canvas for a while. I updated it this morning. No major updates, but let's see. Let me go back here and find it. Here's my syllabus. Let's see where we are. So, excuse me, you have my contact information. Our TA is Grant Romine. He's not here today, but he will be here next Tuesday. Have his contact information. Haven't really set out our office hours yet, but we'll do that soon. Prerequisites. So the prerequisites for this class have knowledge or discrete event simulation in Simeon. So for those of you who are from Auburn, all of you guys I assume, 3420 or 7400 both meet that requirement. And I posted a note on Canvas, an announcement, if you don't have that, or if you would like a refresher on Simeon, we have access to the fundamentals of Simeon scheduling, which is commercial training. It's about 40 hours of commercial training. A couple of you have already signed up for it. If you want to sign up for that, I'm happy to help you do that. Send me the information. If you had 3420 and still remember what you had, if you had 7400 and still remember what you had, you shouldn't need that training. But you're welcome to do it if you'd like. I also have some other resources I'm going to talk about here in just a second. Meeting time and location. So here we are, Tuesday, 4 to 6:50, right here. If we do Zoom sessions, which who knows whether we're going to do Zoom sessions. There's my Zoom contact, always. I have a class schedule page on Canvas. When you go to Canvas, the very first thing you see when you log in Canvas is the class schedule page. And there you see. So what I've done is I've kind of divided the class into an in-person lecture section and a video module section pretty much for every week. So I foresee at this point no weeks where we're going to spend 2 hours and 50 minutes in here listening to me talk. Okay? We're going to every week have some video, some lecture, and my intent is to have discussion type things here and computer type things in video. Sometimes that works well, sometimes that doesn't work quite so well, but that's my intent. Okay? The first one's already there. I posted a note earlier before the semester started, and I have this labeled as Simulation Simeo Refresher. So it's there. You can look at it. 7 videos, about 90 minutes. And it should be a refresher of stuff that you already know. Now, I'm going to talk about this a little later, but keep in mind, this is the very first time this class has ever been offered. Everything is new. All the video modules are new. I did steal my course introduction to what is Simeo from another thing. Everything else is brand new. So when I say you should know the material, that's speculation. If you don't, if you're watching and you say, gee, I had 3420 and I made the highest grade in the class and I've never heard of concept blah, tell me. Okay, so we have Canvas discussion forums. I have discussion forums set up for everything. Talk about it. Go in, say, look, I'm a little fuzzy on this topic, or I've never heard of this topic, and I will go over it. If you tell me, if you ask me questions and say, I need help on this, whatever it happens to be, Simeo related in particular, I will do something. I will do it either in class or with you individually. Okay? If I don't ever hear from anybody, I assume everybody gets it. Okay? So if I hear from nothing from anybody, my assumption is everyone understands everything I said and it's time to move on. Pretty sure that's not the case most of the time. You can fix that by just telling me. Yeah, do you have a question?
How important is animation techniques?
Not that important. The important part of animation for us really is kind of the status type information. So if you like the chart, that like the plot that I showed and status stuff, but if you're talking about 3D animation, it's not that big of a deal for us. Okay, so again, back to what I was saying is, so this is the source of information. Look here. Before you come to class, look here and see if anything's changed. Here's my 4-week forecast. We are today live in person. I plan on being here next week, the next week, the next week. If for whatever reason, by COVID or whatever reason, we went to Zoom, we would just move all the live sessions to live Zoom versus live in here. But we still have, class, the kind of class meeting section. Let's see here. Here's my Canvas syllabus. And so, one more thing with respect to the schedule here. If you watch the videos and you do have questions, I will probably spend some time in the next class talking about those things. Okay, because as I said, if you have problems with something, virtually certain that someone else will have problems too, and so I will spend time, especially if it's topics that I think are particularly important, I will spend time talking. So when you look at each one of our lecture sections, there's lecture material that I want to cover, and there will almost certainly be question material where I'm going to be answering Simeo-related questions or things like that in the live in-person section. Okay. So I have my diversity, inclusion, health, and safety. So again, well-being of students, faculty, staff, utmost importance. I take this very seriously. So if there is anything that you see that I can do better or that we can as a class can do better, please tell me, bring it to my attention, and we will deal with that. COVID-19 alternative operations, who knows? Who knows what's going to happen? I couldn't tell you. But we do have mechanism in place where I could do this all by Zoom, at least my lecture section. So if that happens, we will do that. I hope it doesn't. I would much rather be here in person, but we have that eventuality. We have that possibility, I should say, not necessarily, hopefully not an eventuality. We do have an outreach section, so we have a couple of outreach students. So all the courses, as you know, are getting taped. Everyone will have access to all the videos. So, if you miss class, that's okay. I'd much rather you be here, if at all possible. But you don't have to email me and say, can I see the video? Because everyone's going to see the video. They're going to be available to everybody. We don't really have a textbook here. I don't actually know of a textbook with this material. There's plenty of simulation textbooks. There's plenty of scheduling textbooks. We have a whole bunch of each, have references of each. But there's really nothing that is on target for what we're doing here. Our Simeon simulation text is a good reference for those of you who took the class a while ago. The 6th version of the textbook is now freely available online. It's all there, so you've got the reference to it. Sometimes I will refer to that when we talk about things in class. I think, as a matter of fact, in case study 1, I refer to a section of this book. So again, you have access. Everyone has access to this. There's nothing to buy or any of that. It's all there. Simulation and Simio video module. So I have a whole bunch of set of video modules here. Oops, I didn't mean to do that. Get that guy back. These guys are all on my webpage, jsmith.co. If you just go to educational modules, there's a whole bunch of them. So if I refer you to the Learning Simio Lab series, that's right here. And so I said there were additional resources if you want to refresh Simio. That is one. So the Learning Simio Lab series is designed to be a lab component for an undergraduate course. And so it has, I think, 12 or 14 labs that are targeted to 3-hour labs. And so that goes through pretty much the same thing that you would go through in an undergraduate course. There is the section for our course. So you can see that I have the first 2 up there already. Simulation, Simio Refresher. And then week 2 is the job shop and developing a set of initial Simio models. That's already all there. And the rest of them will be populated as I finish them. A couple other reference texts. So software, I'm going to talk about Simio software in a second, so let me skip that. You can read the course description. You can read the course objectives. I'm not going to read those to you. I'm sure all you guys can read those yourself. In terms of a course topics by week, I'd say the first 4 weeks are pretty good, and then kind of gets a little fuzzy from there on. Practically, or the main reason is I said it's a brand new course, so I have no idea how you guys are going to react to the material. I have no idea whether you're going to come in Tuesday and say, God, that first week, that first video module was so slow. You got to go faster. Or whether you're going to come in and say, I have no idea what the hell you were talking about. You got to go slower. I have no idea where we're going to end up on that spectrum. And so there's a little bit of ambiguity towards the end. But we're going to talk about, today we're doing the introduction. Next week for sure we're going to do scheduling, dispatching, schedule generation, about the general mechanism of scheduling that simulation-based scheduling use. And in the software side, we're going to start talking about implementation. Then we will go through FMS design, and start with case study 2, and then kind of go from there. Okay, and so each week there's going to be, at least the target is each week to have conceptual material, practical application material, conceptual material, practical application material. So I'm trying to balance those to make sure that when we get down somewhere after the exam, it's going to happen on the 7th week, right before spring break, we can then start doing more realistic type implementations because we've covered enough of the theoretical side and enough of the practical side to start dealing with some more realistic size models towards the end of the semester. Course requirements. We are going to have 2 tests. 3-1 is the Tuesday before spring break. 4/26 is the last Tuesday in the semester. Okay, so I'm going to have 2 tests. Each one's worth 20% of the grade. We have 5 case studies. That's going to be worth half the grade. Okay, so you can think of those as homework. You can think of those as project, however you want to think about them. Okay, and they're weighted slightly differently. The first one is 5%. The next 3 are 10%. And the last one is 15%. So you sort of gauge where they fall in. And class participation is 10%. Okay, so I'm going to talk about class participation here in just a second. In-class exams, closed book, closed notes, Tiger Cub excuse, blah, blah, blah. Case studies you should do on your own, but you can and should discuss all aspects of those with your classmates and with me and with Grant. And, discussion amongst yourselves is perfectly fine. When it comes time to actually do the work, do them alone. Unless I explicitly say you can work in pairs or whatever for a particular one. Okay, so again, I want to be clear. I want you guys to discuss. I just want everyone to do their own when it comes time to actually do it. Okay, class participation. So note that class participation is 1 letter grade of your grade. This is the 3rd year I've done class participation like this. I think it's been pretty successful. 10 years ago as a faculty member, I never would have rewarded class participation. I would have just expected it. Kind of grew into this new model here. But let me say, last semester I taught 2 graduate classes. I had 3 students, perfect exams, perfect homework, and all 3 ended up getting Bs. They didn't participate in any way. Okay, now I don't like that. That's not a great outcome. But participation in class is so simple. Okay, for this class, participation includes asking me questions in class, emailing me, emailing Grant, participating in discussions on Canvas, having a Zoom session for whatever reason. Any of those things count. Okay, it's not just asking questions in class, right? So if you go watch video module 1, and say, I don't really understand, arrival tables. That counts, because I'm going to take that, and then I'm going to craft a question and answer and do some stuff in class and so on. So all of that counts. Suppose you put something on Canvas that says, I'm having trouble with the class Simeon license. And someone else comes and answers, here, try this. That's participation. Right? So it's really simple to participate. Okay, it's really simple to participate. Ask questions, participate in discussions. Makes the class better, makes your experience better. More importantly, you get the points for doing it. Okay? And so the model that we use to do this is that we kind of track all of the interactions, and then we give them a score of 1 to 3, depending on intensity. Is it a really simple question? Is it a long discussion? And then we just tabulate the points at the end and do some aggregation. Okay, so that's really what we do. And so when Grant's here, or if he's watching the video, you guys ask me questions in class, he tracks it. All of the stuff on Canvas, we track. All the emails, I'll track. Okay, so participation is really simple, and I promise you it will improve your experience in the class if you do so. Note that coming to class and doing all the homework does not count as participation. It counts as participating, but it doesn't count in your participation grade. You have to actively participate by communication. Okay? Does that make sense? As I said, this is the 3rd year I've done this. I think the results are pretty good. When people participate, they benefit, the class benefits. So I don't know how to be more encouraging than that. I grade on a 10-point scale. 90 to 100 is an A, 80 to 90 is B, and so on. When I curve, I typically curve individual assignments. I rarely curve at the end. If I give you a test and class average is 25, I'm going to curve it. But I do it, on the individual grade average, on the individual grades. And as I said, everything here is new. Every case study's new. Every exam's new. I don't know. If I've given an exam 10 times, I generally have a feel for what's too hard, what's too easy, where it comes down. We don't have any of that experience here, so you have to help me. But believe me, I will adjust. Okay, so again, if stuff's hard in the beginning, don't freak out. If it's too easy in the beginning, don't freak out. We'll adjust. But I can only adjust if I know. So that's why I want you to help me here. Calculator doesn't really apply. We don't really need a calculator. Disability, if anyone here needs any additional information on that, see me. By this time, I'm assuming that everyone who that applies to knows how to deal with it. Academic honesty, I enforce all portions of that, of the Academic Honesty Committee, academic honesty policy. So the major things that we see are cheating on exam, plagiarism, unauthorized collaboration, and then the 4th one I think is multiple submission. I rarely see cheating on exams. It might happen, I just might never see it. I see plagiarism quite a bit, unfortunately, but the plagiarism I see almost always is unintentional plagiarism. Okay, now I have had cases where people intentionally plagiarize, but what I see, I would say 95% of the time is unintentional plagiarism. Like, for example, you go to a web page, you cut and paste, and you don't cite the web page, that's plagiarism. You borrow something from one of your fellow students, copy it in your homework, and don't cite the reference, plagiarism. Okay, so again, what I see when I see that is really unintentional, so be proactive. I want you to use external sources. I want you to go search web. I want you to look in papers and encourage you to do that. But you have to say, okay, I got this information from this source. Okay, and so if there's any questions, see me or ask me or whatever, and I'm happy to talk about that. Unauthorized collaborations, working together when you're not supposed to. As I said, case studies, discuss at length, even discuss results. Okay, but don't do the work together. Don't sit down at the same computer and do the stuff. Okay, that's where we draw the line. You know, if you want to call someone up and say, hey, what'd you get for case study A? What'd you get for the machine 3 utilization? I'm fine with that. Okay, it can't go any further than that, like saying, okay, let me look at your model, let me see where it goes wrong. That's where it really gets tricky. A multiple submission is when you submit something in this class and then you submit the same thing in another class without having permission. For my class, I don't care. If for whatever reason you can use one of my case studies for another class, I'm fine with that. Just tell me. And tell the other faculty member too, right? Because different people have different rules, and it's only a violation if someone doesn't allow it. I allow it, I just want to know it. But the other person also has say also. Okay? All right, anybody have any questions on the syllabus? Any of the details that I gave? Yeah.
So, further down, I noticed that one week is dedicated to Industry 4.0 and digital twins.
You notice what now?
If you scroll a little bit up, there is a week dedicated to Industry 4.0 and digital twins. A little bit up, a little more up. There, number 10.
Yeah.
I was wondering, are we going to use Simeon in the context of Industry 4.0, and if yes, how?
So again, when you look at how we're defining Simeon, we're defining digital twin, and really, I guess, kind of Industry 4.0 also. Where's my PowerPoint? This data-driven process model, that's the Simeon model in our world, in this class's world.
We're going to connect it to a real database.
Yes.
Real-time data from the cloud. Or...
That's my intent. We are certainly going to learn how to do that. Now, whether we can actually connect, to a database that is a real database, is uncertain at this point. But we're going to learn how to do it and what those connections would be. And the difference is, a connection string to a database that's sitting on my computer versus a database that's sitting on someone's SAP. It's the difference between a connection string. That's what we're going to learn. What I hope that we're going to be able to do is connect to some realistic data. But the problem with doing that I haven't been able to solve is of today, proprietary data. You've got to find someone who will share the data. And that's the issue that we're having right now. Okay?
Do you round to like an 89.5?
I do. 89.5 and above, 79.5 and above, and so on. Let's see. Already got through all that. Already did that. Okay. So I mentioned access to the fundamentals of simulation. There's an announcement on Canvas. If you want to do that, see the announcement, and I will be happy to help you. Downloading and installing Simeon. You should have Simeon on your computer. We'll make your life so much easier. We have it in the labs, but it's painful to use. Okay? So you can install it. There's a link. We're going to use Simeon 14.232. Let me just spend a second talking about that. So if you install Simeon and you go to the support ribbon and you look at this number right here, that's the version number. Okay? Okay.
So, if I already have Simeon downloaded on my computer, is there a way to update it without undownloading it and re-downloading it?
Yes. So
I can put that in a discussion question if you want to answer that later.
yeah, you can do that, and I will answer, but I'll give you a quick answer now, and then if you'll ask that question in discussion, I'll answer it so everyone else can see. The key is whether you want to keep the old version. Okay, so if for whatever reason you want to keep 12 point whatever you have or 14 point whatever and install another one on top of it, you have to copy it into another place. I will talk about how to do that in the discussion forum. If you just want to upgrade the version, all you have to do is install it. Download and install. You don't have to do anything with your current install. The licensing will transfer and everything. So if you have either a student license or you have the license that I'm going to show here in just a second, when you install new versions of Simeon, it updates the license for you. There's nothing to do. The only trick, as I said, is if you want to keep multiple versions of Simio, there's a couple things you have to do. Okay? Okay, so there's the link, and in the Canvas page here somewhere, let's see, go back here, go to Pages, view all pages. Here's some instructions. We have a class license. Simio was nice enough to give us a class license. And so you can follow these instructions, and there's the class license key. And the way this should work, I have a different license on my computer, so I haven't used this. Someone will use it and tell me if you run into problems, how this should work. Okay, so you download, so you should have to be connected to the internet to get the license, and then once you have it, you don't have to be connected every time you use it, is my understanding.
I think you do.
You do have to be every time?
So you can do like offline, and then I don't think it cares if you're connected anymore. But then if you do like the online one, there's a trick that you have to make sure you like leave Simio connected to the internet.
Yeah.
Otherwise it's a bug, and that's what it tells you.
Okay. I think that's probably all explained in that PDF document, right? There. And again, class discussion. If you have problems, class discussion is where to do it because someone will know the answer. Someone might be me. Someone might be one of your classmates, but we'll find the answer. If this licensing is new, so again, you guys are the first ones who've used this particular type of license. And as I said, it updates. If you update Simio in the middle of the semester, the license will propagate. You don't have to do anything. Okay. A couple more things. And then
I registered for this Simio class and watched some of the videos. During that videos, I couldn't follow because I was using the old version of the Simio.
Yeah.
So I couldn't follow because some components were missing. So this version has all the components that.
So Simio, let me defer that for just 2 seconds. I talk about Simio Insiders here. And so Simio releases new releases every 3 weeks. Okay, not all of those go to public, but a lot do. Okay, so like on my computer, I don't use 2.32. I have 2.34. Okay, because you can update it. Okay, and so it updates pretty frequently. Okay, now for this class, if you have 2.32, it's fine. You don't have to have the future one. But between now and the end of the semester, there will probably be 2 releases that are done. Okay, and so if you join Simio Insiders, for whatever reason, if you wanted to do it, like for example, one of the things that they're working on right now that they're adding new features to has to do with incorporating neural nets into the model. Okay, so if for whatever reason your research involves neural nets and you want to do that, you want to keep up with those latest features, then you want to install the new one. And you can do that by joining Simio Insiders. Free, easy, simple. Instructions are right there. I would recommend, I would recommend that you do that. So now back to what the videos, like if you take the fundamentals class, that's an old version of Simio. If you look at Learning Simio Lab Series, that's a way old version of Simio. And I think, let's see, when did I do that? Learning Simio Lab Series is 2013, 14? Way old version of Simio. Okay, but the fundamental components are the same. What you don't see is some of the newer stuff. And so when we get into the RPS stuff, the planning and scheduling stuff, that has evolved quite a bit of late. Okay? Okay, so we do video modules. I've already shown jsmith.co. I also have a YouTube channel. So when I put video modules here, they're almost all on YouTube. And what you have is a link to those. Okay? You can also, if for whatever reason you want to, I have a YouTube channel and they're all there, every one of them. All like 500-600 of them are all there, okay? The advantage of going here is that I can put auxiliary files. So if I want to give you an Excel spreadsheet or a Simio model or something like that, I can do it there. I can't do it here. Or I don't know how to do it on YouTube. They also have a Panopto section on Canvas I'm sure you're all familiar with. That's where the course videos will be. Video from that for the outreach will be in Panopto. If we ever do Zoom sessions, the Zoom session videos will be in Panopto. But the weekly modules are going to be in one of these 2 places. Okay? All right, and I will end with, again, the class is new, 100%. Every single thing is new. So bear with me. And we will hopefully, my singular objective is for everyone to get an A in this class. Nothing would make me happier than everyone gets an A. Do the work and we will get through it, and that's really what I want to happen. That's probably not going to happen if you don't do the work. If everyone does the work, I think we'll be happy. I have no objective for anyone to not get a good grade. Okay? And so because everything is so new, you have to help me with that. In particular, tell me when things are too easy or things are too hard or something like that, and I will be happy to go through it. And I have works that we're going to be doing some more fairly detailed things with Simeo through the semester, and I've worked with Simeo since before Simeo was Simeo. So you have to tell me what you find confusing. And when you do, I will be happy to address that in more detail, as much time as it takes, for you guys to get an understanding of what's going on. Yeah.
Very confusing thing for me, at least, is when you don't use the expression builder, it doesn't have any autocomplete.
Yeah, that's true. When you don't use the expression builder, it doesn't have autocomplete. Yeah, that's an annoyance. Yeah, I wish it did. I wish it wasn't that way, but you are not the only person who has noted that.
When you press tab, it's auto.
Yeah.
Yeah.
Just in the expression builder.
The period and the tab do two different things, and you have to have the expression builder. So if you just do it in the properties, you can't do those shortcuts. So when you do a period, it jumps to the next subsection. When you do a space, it says, okay, jumps to the end. Two different, and enter, and so on. Okay, any questions for me? Yeah.
Just to be clear, the video modules are for us to watch before the class, right?
So the video module for Tuesday is the one at the end of this week. So it's like Tuesday, think of it as Tuesday, Thursday, Tuesday, Thursday, Tuesday, Thursday. So the video module trails by 1 week. And so the
7 video series that's on the schedule is for this Thursday.
Correct. Yeah, that's right. And so I put this stuff up early because this first case study, which is the first homework, first case study, is already up and all that. This is based on the first video module. Okay, so it's all there. So, in our schedule, you didn't technically have to watch the video module until after this class. And then if you have questions about it, I'll address them in the next class. I just put them up early because it's the refresher, right? And so my expectation, which I, again, want feedback on this expectation, is that if you had 7400 or if you had 3420 or the equivalent, you should be able to do this case study easily. There should be nothing tricky there. You might have to go look something up. I'm not saying you can sit down in one sitting and do it all, but there should be nothing new. It should all be pretty straightforward. That's why I put it up early. Subsequent ones like 2, 3, 4, and 5 will be more formal as to when they start and what the video is and where in the material that comes into play. Okay? All right, any last questions for me? Okay. See you guys later. Have a great day.